Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is for Course 2, Lesson 5-6, Maps and Scale Drawings. In this section, our objectives are to use proportions to solve problems involving scale. Okay, so we do have a couple of definitions. The first one I've already filled in. A scale drawing is an enlarged or reduced drawing of an object that is similar to the actual object. And by similar, we do mean the geometric definition of similar, where angles are going to be congruent and corresponding sides are going to be proportional. And I should have said corresponding angles are congruent. Okay. A scale is a ratio that compares the length in a drawing or model to the corresponding length in the actual object. Probably the two most common scale drawings that you may be familiar with, a map is a scale drawing. And its scale is usually a certain number of centimeters or inches, represents a certain number of kilometers or miles, might be one that comes to mind. Also, particularly in science, you do have a lot of either enlarged or, enlarged. Think about a cell. Cells are very tiny. When you see a picture in your book, it is a scale drawing of a cell so that you can see and identify the parts, the different parts. Okay, so those would be two everyday applications or school-worthy applications that you might know about. Okay, using a scale drawing. Oh, one other thing you might want to do in general, I try to remember this little ratio, the map or the model to the actual, okay? So M for map or model, A for actual. So map to actual is how generally we set these up. All right, so the scale of a drawing is 1 inch to 6 feet. The length of a wall is 4.5 inches on the drawing. Find the actual length of the wall. You can write the scale of the drawing as 1 inch to 6 feet. Okay, 1 inch on the map represents 6 feet, or drawing in this case, represents 6 feet in real life. Then write a proportion. Let n represent the actual length. So here's my scale, 1 to 6. The drawing, something 4.5 inches long in the drawing, goes on top. And n is the variable that stands for whatever the actual length is in real life. So we do our cross products. So 1 times n is 1n, and then you do 6 times 4.5, which is 27. So n is 27. So in actuality, the length of this particular wall is 27 feet. Okay. So that might be an application of perhaps a floor plan, well, not a floor plan, but maybe a blueprint for a house or something like that. Okay, or it could be a blueprint, excuse me, because it is talking about the length of the wall, not the height. Okay, quick check down here. You may do it now, pause and do it now, or come back to it later. Remember, the choice is yours. Our second example is going to involve a map. Oops. Okay, so find the actual distance from Asheville to Raleigh are the directions. And we see that we have a map here. Asheville is over here, Raleigh to its right. step number 1, and they've told us a little bit of this, would be use a centimeter ruler to find the map distance from Asheville to Raleigh. The map distance is about 4.4 centimeters. So if you actually have a ruler at home, you might want to check that you could see why they wrote down 4.4. If you don't, basically it's taken one of these, a ruler, and measured the distance apart. Okay? Use a proportion to find the actual distance. Let n represent the actual distance. Okay, so I need to have my scale. And oftentimes on a picture or a map, your scale is going to be represented or indicated by this little key or this information. So it's telling us that 1 centimeter corresponds on the map corresponds to 75 kilometers in actuality. So 1 to 75 equals the map length of 4.4 over the actual length. Again, map to actual, map to actual. So you do your cross products. So 1n equals 75 times 4.4. Whoops, 75, not 7.5. Sorry about that. It's a little ugly, but it is 7.5. And when you multiply those together, you get n is equal to 330. So the actual distance from Asheville to Raleigh is about 330 kilometers. In this case, there should be a measurement attached to your final response because that is in fact what you are trying to find. The next one is finding the scale. So if you know some things about, sometimes you have to figure out the scale yourself. Generally in a scale, we're going to usually want our top number to be a 1. It's not an absolute, but it's a very common practice that 1 inch, 1 centimeter, 1 foot, something like that represents a second value. And whatever that second value is, it is. Okay. So the actual length of a wheelbase of a mountain bike is 260 centimeters. The length of the wheelbase in a scale drawing is 4 centimeters. So again, I went model to actual, model being the drawing. Okay, so you can think drawing to actual as well. So 4 in the drawing, 260 centimeters in real life. What I want is I want the ratio in simplest form. Generally, not always, simplest form is a rule of thumb. Generally, though, we do want this to be a 1 on the top. So I'm going to divide that by 4, each one of them. So that gives me 1 to 65. So the scale is 1 centimeter to 1 centimeter on the drawing, or in the drawing, represents 65 centimeters in real life. Again, map or drawing to actual. Okay. All right, so number 2 is find the actual distance from Charlotte to Raleigh, and number 3, quick checks as well. Just a quick little hint, if you do not actually have a ruler available, you could mark off the distance using just the edge of a sheet of paper and then lay it over this ruler here and use that amount as well if you don't have something to measure with at your convenience. Okay, so have the quick checks done. Any questions you have, bring along as well. I look forward to seeing you soon. Bye now.